All right, let's dive right into our first topic. Understanding the structure and organization of the internet. Now, this is a vast topic, so let's break it down to make it easier to digest. So you might have heard about servers and clients, right? Well, let's start with them. The internet is essentially a massive network of networks, and at the heart of these networks are servers and clients. Servers are powerful computers that store and deliver data, and clients are devices like your laptop or smartphone that request that data. Imagine you're at a restaurant. The server is like, well, the server, and you're the client. You ask for a dish, and the server brings it to you. Similarly, when you click on a link or open an app, your device sends a request to a server, which then delivers the data you asked for. Pretty simple, right?
Now let's talk about protocols.
These are like the rules of the internet, the language that servers and clients use to communicate with each other. The most common one you'll come across is HTTP, which stands for Hypertext Transfer Protocol. This is the protocol used for transmitting hypertext, the core of any web page, over the internet. Then there's TCP/IP, or Transmission Control Protocol, and Internet Protocol. These two work together to ensure that data from servers reach the right clients. Picture it like this. You're sending a letter. TCP is making sure that your letter is properly addressed and packaged, while IP is your postal service, ensuring the letter gets to the right address. So in a nutshell, the internet works on a client-server model. It relies on protocols to ensure smooth communication between them. It's like a giant global conversation happening in a language of codes and protocols. Fascinating, isn't it? But as we'll see, there's a lot more to the internet than just that. Stay tuned. So let's move on to our next topic. The role and function of internet service providers, or ISPs as they're commonly known. We can't talk about the internet without giving these guys a shout out, right? ISPs are the organizations that provide us, the users, with access to the internet. They're like the gatekeepers of the internet. You might be familiar with a few of them. Companies like AT&T, Comcast, Verizon, and so on. How do they do it? Well, ISPs have their own networks, typically made up of high-capacity data lines, which can handle large amounts of data. They also have a lot of powerful equipment, like routers and switches, to manage and direct data traffic. Here's an interesting analogy. If the internet were a city, ISPs would be like the transport companies. They own and operate the buses, trains, and taxis, the network infrastructure, that take people, data, from one place to another. Without them, the city wouldn't function. ISPs connect to each other to form larger networks, and these are then linked together to create the internet as we know it. They even exchange traffic at places called Internet Exchange Points, or IXPs. It's like a massive global meetup of data. But ISPs don't just provide access to the internet. They also offer other services, like email, web hosting, and virtual private networks, VPNs. So, in essence, ISPs play a crucial role in connecting users to the internet. Without them, we wouldn't be able to surf the web, stream videos, or...
Well, watch this video right now.
But remember, ISPs are just one part of the bigger picture. There's a lot more to the internet than meets the eye, and we're just getting started. On to the next topic. All right, let's continue our journey with the next segment. Analyzing how data is transmitted across the internet. This involves concepts like packets, IP addresses, and routing. So buckle up because we're about to dive deep into the heart of the internet. So how does data travel across the internet? Well, it's broken down into smaller pieces called packets. Think of packets like tiny digital envelopes containing bits of information. Breaking data down into these packets helps to ensure it can travel more efficiently across the internet. Each packet is then stamped with an IP address. This is essentially a unique identifier for each device connected to the internet. It's like the postal address for your device. This IP address helps ensure the packet reaches the right destination. Now, on to routing. Routing is the process by which these packets find the most efficient path from the sender to the receiver. It's like the GPS system for data, guiding each packet along the best route. Routers are those in your home, and the larger, more powerful ones used by ISPs play a crucial role in this process. Imagine you're sending a letter across the country. The letter is like your data. The envelope is the packet. The address on the envelope is the IP address. And the Postal Service deciding the best way to get your letter to its destination is the routing process. And here's a fun fact. Not all packets from the same piece of data necessarily take the same route. They're all independently seeking the most efficient path at that moment. It's a bit like if you and a friend were both driving to the same place, but took different routes based on the current traffic. So, once the packets reach their destination, they're reassembled into the original data. It's a complex process, but it happens in milliseconds, allowing us to stream movies, play online games, and browse the web smoothly and efficiently. So that's the basics of how data is transmitted across the internet. It's like a high-speed, high-stakes relay race with packets of data zipping around the world in the blink of an eye. It's fascinating, isn't it? But we're not done yet. There's still more to explore, so let's keep going. Now, let's move on to our next exciting topic, investigating the global scope of the internet. This includes the fascinating world of submarine cables and satellite connections. You might be thinking, wait, the internet is in space and under the sea? Well, yes, and it is quite the story. Let's start with submarine cables. Despite what you might think, the majority of international data isn't transmitted by satellites, but by cables laid on the ocean floor. These submarine cables are responsible for transmitting almost all of the world's data across continents. These cables, often no thicker than a soda can, are laid down by specialized ships and can stretch for thousands of miles. They're made up of multiple layers, including protective materials, fiber optic threads for data transmission, and even a layer for shark protection. Yes, sharks have been known to bite these cables. Now, on to satellites. While submarine cables handle most of the heavy lifting, satellites play a crucial role in delivering internet connectivity to places where cables can't reach, like remote islands, airplanes, and ships at sea. Satellites orbiting the Earth receive signals from a ground station and then beam those signals back down to a different location on the planet. This allows data to literally cross oceans and continents at the speed of light. But satellite internet has its challenges. For one, it can be affected by weather conditions. And there's also a noticeable delay due to the distance the signal has to travel. However, advancements are being made with the advent of low Earth orbit satellites, which promise to provide faster, more reliable connections. So whether it's through cables deep under the sea or satellites high above in space, the internet truly has a global reach. Remember, it's a testament to human ingenuity, connecting people and places that would otherwise be worlds apart. But remember, with such a vast network comes challenges, especially when it comes to security and privacy.
And that, my friends, brings us to our final topic. Stay tuned.
Now, let's delve into our final topic.
Exploring security and privacy issues related to the internet.
This involves encryption, firewalls, and data protection laws. All crucial aspects in maintaining a safe and secure internet for us to use. Let's kick things off with encryption. Encryption is like a secret code that scrambles your data, turning it into a jumble of characters that only someone with the right key can decipher. This means that even if someone intercepts your data, they can't understand it without that key. It's a little like passing secret notes in school. Remember those.
Next up, we have firewalls.
A firewall is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on a defined set of security rules. Picture it like the bouncer at a club deciding who gets in and who doesn't based on the rules set by the club owner. Last, but certainly not least, we have data protection laws. These are laws and regulations that set out rules around how organizations can collect, store, and use personal data. A well-known example is the General Data Protection Regulation, GDPR, in the European Union. These laws are designed to protect our privacy and give us control over our personal data. Security and privacy on the internet is a vast and ever-evolving field. As technology advances, so does the need for more sophisticated security measures and stronger data protection laws. It's a constant game of cat and mouse, but it's crucial in ensuring our personal information stays just that, personal. So there you have it, folks. We've traveled from the vast network of servers and clients to the world of ISPs, across the routes data takes to zip across the globe, dived deep beneath the sea, and soared high into space. And finally, we've touched on the important world of internet security and privacy. The internet is a vast, complex, and fascinating world, with so much more to explore than we could possibly fit into one video. But hopefully, this is giving you a good starting point. Remember, knowledge is power, especially when it comes to navigating the digital world. So stay curious, stay informed, and most importantly, stay safe out there. Until next time.